Welcome to the U.S. Military Test Prep channel by Study.com. My name is Eric, Marine Corps veteran, and I'm an ASVAB test prep expert. In today's video, we'll practice using slope to identify parallel and perpendicular lines and to solve geometric problems. This will help you prepare for the Mathematics Knowledge Exam, which is one of the subject-specific sections of the ASVAB. Let's take a look at our first problem. Use the graph below to answer the question that follows. Which linear equation is parallel to the linear graph above? And in this problem, we're referring to this graph here, and our answer sets appear in slope-intercept form. So let's review slope-intercept form. Y equals mx plus b. M is our slope, and b is the y-intercept. So an important thing to understand when solving a problem where you're trying to find parallel lines is that there's really one thing that's important. A parallel line is defined as a line that has the same slope. So this m, slope, is really the only part that matters. We're looking for an equation of a line that shares the same slope as the line depicted on this graph. And we have a lot of information in this graph. We can actually see where the line intersects here. So let's review some of the other equations we've seen that depict the form of a line. So we'll start here with the point-slope form of a line. So in this case, if we have one point, we could put those pieces in here, but what that's really going to help us find is b. That's going to help us find the y-intercept, which isn't helpful in this particular problem. So now let's look at the two-point form of a line. If we can find 2 points here, then it looks a lot like the point-slope form of a line. You know, this part looks just like this part, and this part looks just like this part. But this m, the slope that we're looking for, is what's different. Here is an equation where we can find m. And what that equation is really helping us to do is to identify the rise and the run, because a slope is really just defined as the ratio of rise to run. So what we can do is we can pick 2 points. And I'm going to pick 2 points that are easy because they're good whole numbers. Like right here is a great one. It's on 0 here. And then it's right on the 2. So we'll call this point A, and point A is 0, that's our x-axis, 2 is the y-axis. And the next one down the way that I see here, here's another really easy one that I can use. We'll call this point B, and this is going to be 5, and then our y is 0. So our rise is basically the change from point A in the height on the y-axis here to where it ends up on point B, the height of the y-axis. So our rise, we start at 2 and we end at 0. So that's what we're doing right over here, is we're saying point 2, or B, our y is 0 minus, and point A is 2. And our run is basically the change on the x-axis. That's kind of this distance right here. So that's where we're saying our x2 is 5 minus our x1 is 0. So our rise is -2 and our run is 5. -2 and 5. And so our slope is -2/5. So now all we have to do is come over here and look at our answer choices and find the one that has a slope of -2/5. And that's right here. So that means that the equation for the line in answer B is parallel to the one depicted on the graph because it shares the same slope. So that's our answer. Great job. Line A has an equation of y equals 2x minus 5. What is the equation of a line that passes through point 0,3 and is perpendicular to line A? So let's talk about what it means for a line to be perpendicular. If we were to graph our x and y axis out here, and let's say we had a line that looked like this, a perpendicular line would run this way. So we're not looking for something that shares the same slope. We're looking for something that has a negative reciprocal slope. So if this is our line A, and this is our line B, then if the slope that we're looking for is equal to the negative reciprocal, so that would be -1 divided by our known slope. So let's fill that out. This is m1 equals -1 divided by and we have our known slope here. This is m right here in our slope-intercept form of the line. So since that's provided, we'll go ahead and fill that in. That means that the slope we're looking for is -1/2, which can also be read as -0.5. So right off the bat, we can eliminate these two answers. We know that isn't it. Now answers A and B have the slope we're looking for of -0.5, but we don't have all the information we need. How do we know which one is it? Well, that's where this second part of the question matters. It says, what is the equation of a line that passes through 0, 3 and is perpendicular? So we know what the slope has to be in order to be perpendicular, but we need this last piece here. We need to know which one of these is correct, and that's our B. That is our y-intercept. So let's look at our equations of the line over here and figure out which one do we think that we could work out. Well, we figured out our slope. We have that, and we're given one of the points here, 0, 3. So I think we could plug that in right here. So it seems to me the point slope form of a line can really help us out here. So let's substitute in what we have. Y minus, and our y1 here is 3 equals, and we solved for our slope earlier, so that's -0.5 times x minus, and our x1 is 0. Great, well we have a lot of information here, so we should be able to work this out. Y minus 3 equals -0.5x minus, and then -0.5 times 0 is 0. So if we add 3 to both sides, then we get y equals -0.5x plus 3. So that's our answer. Great job. Line M has an equation of y equals 4x minus 3. What is the equation of a line that passes through point 1, -2, and is parallel to line M? So let's just draw a rough graph here just to remind ourselves what we're looking for. So if this is line M, then a parallel line would run just like this. So that's really what we're looking for, is a parallel line. And we know a line is parallel when we look at this slope-intercept form of a line. If the slope is the same, we know that a line is parallel. So since we're given the slope in the problem of 4, we know that the slope that we're looking for in a parallel line has to be 4. So right off the bat, we can eliminate these top two answers. So we just have to figure out which of these bottom two is the answer we're looking for. The only thing we're missing is B, which is the y-intercept. We need to know which one of these is the correct y-intercept for the line that we're looking for. So let's review our different equations here for the forms of a line. It seems to me this point slope form of a line could really help us out because we have M, we know that's 4, and then we're given a point that the line we're looking for has to pass through. So our y1 here is -2 and our x1 is 1. So with that information, let's substitute in what we have and see if we can solve and find our y-intercept. Y minus -2 equals 4, because it's a parallel line, times x minus 1. And that's y. And we'll say plus 2, because our negative signs cancel each other out here, equals 4x minus 4. So then if we subtract 2 from both sides, we get y equals 4x minus 6. So that's our answer. Great job. Okay, that's the rundown on using slope to identify parallel and perpendicular lines and to solve geometric problems. To recap, remember to read the entire question carefully and consider what information you are being given to solve the problem. Writing out known equations and substituting information given to you in the problem can help make it clear what steps are needed to find the solution. The Study.com ASVAB course includes more information about what each subtest covers. The question content is similar to what you'll see on the ASVAB, and practice test scoring will be broken down by subtest for line score calculation. That can really help you see where you stand. If this video helped you out, give it a thumbs up, drop a comment with any questions or topics you want us to cover, and don't forget to subscribe for more U.S. military test prep content. I'll see you in the next video. You've got this.